A very good morning to all of you. I cordially welcome you all for this engineering thermodynamics course. So today we are going to discuss about the two important topics. So these two topics I have identified as self-learning topics. So the first one is control value, control mass systems and continuum theory. Second one is macroscopic and microscopic point of view thermodynamics. So these two topics we are going to discuss in the today's class. So what is the motivation to study these particular topics? That is why we have to study this control volume, control mass and continuum theory, all these particular topics. So it is very important to know that behavior of the matter is considered according to the macroscopic or microscopic point of view. So the reasons for considering macroscopic thermodynamics in our syllabus is also to be discussed. That is, whenever we are having the microscopic as well as the macroscopic. So there are two approaches are there whenever we are studying the behavior of the matter. So microscopic study is known as the statistical thermodynamics. Macroscopic is known as the classical thermodynamics. So some of the textbooks are written in such a way that classical thermodynamics for engineers. So indirectly is saying that we strictly followed macroscopic behavior of the study in our textbook. Even though unless until specified, so we are strictly following macroscopic behavior of the study only in our normal engineering thermodynamics textbooks. So what is the difference between the microscopic behavior and macroscopic behavior, and why we are considering only macroscopic study in our syllabus and in our textbooks? That we are going to discuss in the today's class. That is the motivation. And similarly, what is the outcome after completion of this lecture? So you should be able to differentiate macroscopic and microscopic thermodynamics. That is the outcome I am expecting after this lecture. So here, whenever we are having a thermodynamic system, so it can be classified according to control value and similarly according to the control mass. So whenever we are able to distinguish according to the control value, it is once again it is known as the open system. Control mass. So control mass once again it is classified into the closed system as well as isolated systems. So here in the whenever we are having one example, let us say that air compressor is there. So in the air compressor, we are sending the air in this particular form, and for our purpose, so whenever we want to retrieve the energy from this air compressor, so the air is taken from this air compressor like this, is the air is out. So if you want to run this air compressor, so it should be connected to the motor by means of a shaft. So that is whenever power input is given to the motor, so initially the motor will be started, and the motor is attached to the compressor by means of a shaft. So the shaft will be rotated. By this, the air compressor will start its functioning. So what do you mean by the control value? That is here I have written for thermodynamic analysis of an open system. That is almost all engineering devices will be considered as an examples of the open systems only, like a boiler, turbine, nozzles, diffuser, compressors. So that is you take any engineering device that can be an example of the open systems. So here one example we considered here is the air compressor. Air compressor, so attention is focused on a certain quantity of a matter surrounding the compressor known as the control value. So this entire one is known as a dashed line. It is known as the control value. That is, it is a control value and it is the control surface. So that is our attention is basically concentrated on this particular area. So area of the matter, what we are going to study, the behavior of the matter, that is known as this control value. So which is bounded by a surface called the control surface. That is, the control value is always surrounded by a surface which is known as a control surface. That is, so through which the work interactions as well as the heat interactions are taking place. So whenever we are coming to the closed system, that is here there we are having the control mass, that is there is no mass transfer, there is only energy transfer is taking place. But here in the control value, both mass transfer as well as the energy transfer. That is the air in and air out. That indicates that the mass is transferring. And similarly, work and heat, that is the energy transfer is taking place. So both mass transfer as well as the energy transfer both are taking place. That's why it is known as the open system, or which is known as the control volume approach. But in the control mass approach, it is a closed system and similarly the isolated system. So there is no mass transfer in the closed system. There is only energy transfer will takes place. So that is the difference between the open and closed systems. So here you are able to see, because in the control mass, so in the control mass means, so mass transfer is equivalent to zero. That is, there is no mass transfer. But in the control value, definitely there will be a mass transfer and energy transfer. So here I have written that is a mass plus identity is fixed in case of the control system. So the mass is equivalent to zero. So that is the difference between the control value as well as the control mass. So whatever the thing I have explained so far, that is the control volume as well as the control mass. So control volume, so both mass transfer as well as the energy transfer. But in the control mass, so it is subdivided into the closed system and isolated system. So in the closed system, there is no mass transfer, only energy transfer is taking place. But in case of the isolated system, so there is neither mass transfer nor energy transfer is taking place. So there is no interaction between the system and surroundings, that is known as the isolated system. So like that, we can differentiate the control volume approach as well as the control mass approach. So the same thing I have written here. So in the control volume, so the volume is fixed. So volume is fixed. So that is the boundaries, because I told you that the system and surroundings are separated by means of the boundary. So the boundary may be the real one or boundary may be the imaginary one also. So the system and surroundings will put together, it is called as the universe. So that is the basic concept. So that is how can we define this control value and control surface. That is whatever I have explained so far, the same thing I have presented here. So please go through the slides. And next one, it is the macroscopic and microscopic behavior of the study. So that is macroscopic approach. That is, it is a vast, it is a very big. So that is the total, that is the meaning of the macroscopic. That is, we are not considering into the individual molecules behavior in the macroscopic. That is the total system behavior we are only considering. But whereas in the microscopic behavior, we have to consider the each and every element behavior. That is, what is the pressure, what is the value, what is the temperature, what are the other property values at a given point of a molecule. So that we have to consider in the microscope. That is, we have to pay our attention to each and every individual molecule behavior. So that is very, very difficult whenever we are dealing practically. It is very, very difficult approach. So that's why we are strictly going for only the macroscopic approach. That is, we have to consider only, that is, whenever you are measuring the pressure, so that is the pressure, that is the average pressure of the system only we are taking into the consideration. It is average force only we are going to consider, not the force of individual molecules or pressure of individual molecules we are not considering. That is, we are taking the total pressure, the total, that is the average molecules, that is the pressure of average molecules which are presented within the system. That is a macroscopic behavior, that is a classical thermodynamics. So that's why we are considering only the macroscopic, because the microscopic is very, very difficult. So that is, how can you differentiate the macroscopic behavior as well as the microscopic behavior. So the same thing whatever I have told you here, that is the macroscopic, the analysis of macroscopic system requires only simple mathematical formulas. But here in the microscopic, the behavior of the system is found by using statistical methods. That's why it is known as the statistical thermodynamics. It is known as classical thermodynamics. So statistical methods, as the number of molecules is very large, so advanced statistical and mathematical methods are needed to explain the changes in the system. So it is very, very difficult approach. So similarly, the another important one is, in order to describe a system, only a few properties are needed in the macroscopic, but in the microscopic, large number of variables are needed to describe the system. So the system will become very, very complicated. So normally that's why we are keeping aside this microscopic behavior of the study. So we are only concentrating on the macroscopic behavior of the study, that is the classical thermodynamics. So the same thing, that is the pressure, volume, temperature, just we are considering only the average effect of the molecules in the macroscopic. But in the microscopic, the each and individual element, that is the ith element or the I molecule, so that we have to consider here in the microscopic behavior of the study. So here the continuum theory. So the concept of the continuum is a kind of idealization of the continuous description of the matter, where the properties of the matter are considered as continuous functions of space variables. That is important one, space variables. So that is this is also linked with the fluid mechanics also. So in the fluid mechanics also we have to consider this continuum theory, and similarly whenever we are discussing about the heat transfer also, because the heat transfer is also more or less related to the fluid mechanics, so there we can study and elaborate about this continuum theory. So that is in the today's class we have discussed about that is macroscopic behavior and microscopic behavior, the differences, and similarly the control value and control mass approaches whenever we are dealing with a thermodynamic system. I hope you understand these important concepts. So that's why these are labeled as self-learning topics. So thank you very much for listening this lecture. Once again, we will meet you in the next lecture. Thank you very much.